Welcome back to the Curdverse. I'm Lisa Kaywood, corporate functionary by day, home cheesemaker by night. Last time we talked about bloomy rind cheeses, and today we'll continue our tour of fabulous cheese fungi with a look at blue cheeses. In episode 7, I shared a story about Charlemagne allegedly being served moldy cheese of some sort and being counseled not to scrape off the mold. It's often used to show that blue cheese, specifically Roquefort, dates back to at least Charlemagne's time. Or maybe it was Brie. Depends on who's paying your bills. Now, Charlemagne may or may not have sampled Roquefort specifically, but there was definitely blue cheese to be had in Europe in his time. And there had been for at least 1500 years before that, probably much before that. Mainly because blue molds will happily grow on all kinds of food, given pleasingly cool, damp conditions, whether you want them to or not. They're so aggressive, in fact, that some commercial cheesemakers mandate entirely separate buildings for making and aging blue cheese, to ward off cross-contamination from cheeses that they don't want to be blue. So if you stick any kind of cheese in a damp cave for a while and don't tend it regularly, you're very likely to come back and find blue cheese. In fact, that's part of the origin stories for both Italian Gorgonzola and French Roquefort. Once upon a time, the stories go, there was a shepherd, or a cowherd, out somewhere in the hills tending his animals, carrying with him a lunch of bread and cheese. At some point, he somehow syncs up with a young lady who happens to be also out wandering alone through the hills, and they duck into a cave for reasons. And being distracted with other business, the herder entirely forgets his lunch until a few weeks later, when coming back to the same spot, he remembers and goes into the cave to look for his food, only to find it all covered in blue mold. I will note here that the origin story for English Stilton involves no mention of romantic activities, only commercial ones involving a widow. Make of that what you will. The cave part of the Franco-Italian story is really key, caves being wonderfully cool, damp places. And in fact, the oldest evidence that we have to date for human consumption of the type of blue molds often found on cheese and bread comes from a cave. A specific cave in the Austrian Alps, above a little village called Hallstatt. Hallstatt sits on the edge of a brilliant blue glacial lake in a valley that's shaped like a steep bowl. There's a very narrow inlet into the valley from the north. The water in the lake finds its way down into the lowlands north of the Alps in a series of streams. And nowadays there's a very narrow 2-lane-ish road that's been carved out of the side of the mountain right above where it drops into the lake. The rest of the valley is high, steep walls, topped still with the remnants of what were once significant glaciers. Between the stony peaks and the lake, there's a swath of light woods and some open meadows just above the tree line. But the reason that Hallstatt is special and pertinent to our story today is those caves. So hundreds of millions of years ago, before the Alps were even formed, in fact, after the supercontinent of Pangaea had just started breaking up, what is now the southern half of Europe and North Africa was covered by a salty ocean known as Tethys, which also stretched across what is now Asia and perhaps as far as New Guinea. As the land underwent various uplifting and buckling episodes over the course of eons, portions of that sea would get separated from the larger body of water, and they would dry out, leaving behind deposits of limestone and salt. This is why there are so many of those immensely useful limestone caves all over southern Europe, by the way. But specifically in the Austrian Alps, there are very large deposits of salt, and people began mining that salt from the mountain above the modern village of Hallstatt at least 3,500 years ago, during the Bronze Age. Now, salt is great for preserving cheese, as we've discussed. It's great for preserving all kinds of things, which is why the wood, leather, and various organic human artifacts found in and around the mine are in such exceptional condition that it's possible to extract all kinds of biological information from them, such as what people working in the mines ate. Because they definitely did not hike all the way back up to the surface every time they needed to do their post-meal business. So archaeologists have been able to study this protohistoric poop, and last year, in October 2021, they shared their findings in a paper that I've linked to in the show notes. The long and the short of it is that in addition to wheat and millet porridge, perhaps sweetened with foraged berries, they occasionally had a bit of meat, and by the Iron Age were definitely eating cheese and beer. Specifically, blue cheese, because in one of the Iron Age samples from around 600 BCE, they not only found high concentrations of Lactobacillus and Brevibacterium bacteria, which are associated with fermentation in general, and dairy fermentation in particular, but they also found Penicillium roqueforti. That's right, the mold that makes Roquefort cheese a blue cheese. Now, this is not to say that our Iron Age salt miner was eating something that tastes just like the kind of Roquefort that we eat today. Penicillium roqueforti is actually an extremely generic term, kind of like calling something a dog. It basically just tells you something about the general properties of the mold you might find yourself with. There are over 600 substrains of Roqueforti that have been scientifically classified, and probably many more that haven't been. And not all of them have equally tasty effects. The dark purple-blue mold that naturally lives in my area, sadly enough, makes a cheese taste musty with an odd, acrid peppermint flavor. If I'm not paying attention, it gets a foothold. The ones you have in commercially made blue cheeses are only a very, very small subset that have been carefully selected and are continually repropagated in the factory. We also don't know anything about what kind of cheese it may have been in the Hallstatt mines. Was it soft or firm, big or small, did it have rennet? One thing that's pretty reasonable to assume is that this cheese that was produced next to a major salt mine was probably fairly salty, and that's important in the production of blue cheeses for reasons I'll get to in a minute. We also know that both the ancient Greeks and Romans with whom our Austrian miners traded were greatly impressed with the size of the cow herds of their northern neighbors, and later Roman writers were also greatly impressed by their huge wheels of cheese. Now, so far I've been talking about blue molds growing on things, because that's what they naturally do given a chance. But by and large, the blue cheeses we're used to buying in the stores have the blue mold on the inside, and the rind, if it has one, is white. So it gives. So here's where we need to talk about how blue cheeses are made. The blue mold spores live everywhere, in the air, in the milk, on the walls of cool, damp surfaces, like caves. But modern cheesemakers, and probably later medieval ones as well, deliberately inoculate the milk with blue mold taken from some moldy bread or previously made blue cheese, or freeze-dried ones from a packet when they go to make the cheese. Sometimes they'll also sprinkle powdered mold spores over the surface of the curds just before they're put into molds. This ensures sufficient quantities of mold spores are present throughout the cheese, so they'll reliably fruit once the cheesemaker creates the right conditions for them. Blue molds thrive in high moisture, low oxygen environments, and they're more salt tolerant than many other yeasts and molds. And one thing they really like to eat is acid molecules, or lactate. So when you make a blue cheese, you start out by giving your starter lactobacillus cultures plenty of time to convert the lactose in the milk to lactic acid, producing a high acid curd. And that gives your blue molds lots of food to eat as they start their growth. After the cheese is formed, the outside is dry salted, enough that even the blue molds find it hard to get started on the surface, which is why the outside is able to dry out and then be treated in various ways to avoid too much mold growth on the rind. Blue cheeses are pretty high moisture cheeses, and they're not pressed, so there are lots of little crevices within the cheese where the curds are just resting lightly together, and that provides just enough air inside the cheese for the blue mold spores to start to fruit within the cheese. And so there they sit, in the dark, munching on the acid molecules in their immediate vicinity, and producing carbon dioxide and a certain amount of ammonia as they digest, kind of like your Uncle Frank. A couple of weeks after the cheese is formed, the cheesemaker then pierces the cheese in several places to let out those accumulated gases and give the molds inside a fresh supply of oxygen. You may have noticed that the veins in some blue cheeses look needle straight. That's where the piercing skewer went in and left a hole behind where the blue molds could fruit aggressively. Blue molds also really like fat and protein, so they break those down fairly aggressively during aging as well. A lot of cow's milk blues are made from breeds that produce higher fat milk, and sometimes even cream is added. Naturally high-fat, high-protein sheep milk is preferred for Roquefort cheese for the same reason. These processes of breaking down fats and proteins are still relatively slow compared to the lactate consumption, but they produce a whole range of chemical byproducts that introduce complex flavors into the cheese that normally take many months, even years, to appear in slow-aging mold-free cheeses like your Alpine and Harder cheeses. So all those different flavors you have going on in a blue cheese, it's not necessarily the flavor of the mold itself, which is why you don't have non-integrated sharp jolts of flavor when you bite into a blue vein. That symphony of flavors is actually the side effect of how the mold has processed the curd before you get to it. So it's worth explicitly drawing the point out here. Whereas the white, bloomy rind cheeses age from the outside in, because the molds are eating their way in, interior veined blue cheeses age from the inside out. Something else happens to the molds as they work their way out towards the surface. They encounter the salt that was liberally sprinkled on the surface of the cheese way back when it was first born, and which over time is slowly absorbed by the moist interior portions of the cheese. And while blues can deal with some salt, like 1 to 3%, it does make them less aggressive, and it changes how they grow. Instead of growing clusters of thick mycelia branches, remember, blue molds are fungi, they're stimulated to grow more spores instead. And the spores are the part that have that blue-green color. And at high enough salt concentrations, they just don't fruit at all, which is why in some cheeses you'll see more blue towards the interior of the cheese and less near the rind. There are, of course, innumerable types of blue cheeses in the world, but the most widely recognized big three are French Roquefort, Italian Gorgonzola, and English Stilton. A lot of North American blues will describe themselves as being in one of those styles. Roquefort is a sheep milk cheese and Gorgonzola is a cow's milk cheese, but they're made in pretty similar ways initially. Very, very soft wet curds are scooped up and ladled into the forms and allowed to drain at room temperature for several hours or even a day or two. After that, they move to a cooler cave for their first couple of weeks until they're pierced. That's where they part ways. The Roqueforts, as well as some cow's milk cheeses like Bleu de Causse, Saint-Augure, and the mild Danish and American Maytag blues, are cleaned up and wrapped in foil or wax after enough blue has grown in the interior so that no distinct chewy rind develops. These are called rindless blue cheeses. Gorgonzola, meanwhile, is kept in cold environments after the initial blue fruiting and allowed to develop a rind. The blues tolerate the cold better than most other molds, so they continue to grow in the interior, but the drier, salty rind is less appealing for them, and the cold keeps most other molds, besides a bit of geotrichum, from taking hold. I've got a link to an annotated video of Gorgonzola manufacture in the show notes. The French Fourme d'Ambert is another famous rinded blue. In some places, leaves like grape or chestnut leaves are soaked in the local spirit and then used to cover the rind to keep off molds. Spanish Cabrales and Vallejon are good examples of this, and Rogue Creamery in Oregon makes a version as well. Meanwhile, Stilton and the raw milk Stilton are milled curd cheeses, like many cheeses in the British Isles. I'll spend another episode talking about milled curd cheeses in more detail, but essentially these are somewhat drier cheeses, and the curds are salted before being put into the mold. Because of the salt on the exterior of each curd, they don't squish together as easily as the wet Roquefort and Gorgonzola curds, so you get a more crumbly cheese with lots of interior nooks and crannies in which the blues can grow. But they also don't grow too aggressively because of the direct presence of the salt throughout the interior of the cheese. I'll have a link to an annotated video on this process as well so you can see the difference from the Gorgonzola. The degree to which any of these cheeses is more or less strongly blue depends on a number of factors. The specific type of blue mold used, for example, some are more aggressive in their consumption of fat and protein and produce a greater number and possibly greater variety of flavors. How much salt is used and when and how will also influence the development of the blue molds. How much of the interior gets exposed to air, so how much of the cheese is pierced, will also drive blue development. There are actually two other major categories of blue. The first is a relatively new one, probably from the 19th century, and that's the bloomy rind blue. Cambozola, a German cheese, is the classic example of this type, but there are many other cheeses of this style from France, England, Scandinavia, and the US and Canada, because they're a very crowd-pleasing form of blue, relatively mild with that creamy, gooey mouthfeel of a camembert. They're generally fairly small, younger cheeses like other bloomies, and unlike the big three types, which are very tall and typically age for several months. These bloomy rind blues are pierced, like other blues, but then after the blue develops in the interior, the surface is misted with a light brine solution containing the white mold Penicillium candidum and Geotrichum spores, which are then allowed to grow in over a week or so. Because you now have blue molds breaking things down from the inside out, and white molds gnawing away from the outside in, you have a nice gooey cheese in a relatively short period of time. The final category is a surface-ripened blue. These are relatively rare in the modern era. You'll sometimes find logs of Chèvre in this genre. Chèvre, again, is a high-acid, high-moisture cheese, so if the milk is inoculated with blue spores, the spores will happily fruit on the surface of the cheese. And just like white molds, the blues will start to break down the cheese from the outside in, so you'll get a bit of a gooey cream line inside the blue mold rind before you get to the creamy Chèvre center. The last kind, the surface-ripened blue, is most likely the oldest kind, and possibly what our Iron Age miner in Hallstatt was eating, more or less because that's just what happened to the cheeses stored inside the mine. We don't really know when exactly people started realizing they could get more blue molds if they pierced their cheeses, much less that it would actually taste good. But there's a clue in the tale of Charlemagne that I shared in the Bloomy Rind episode last time. So in that tale, after Charlemagne decides he actually likes this moldy cheese from which he originally scraped off the mold, he orders 2 wagon loads to be sent to his palace every year. But the abbot who served him this cheese gets really nervous and he says, "But sir, I can obtain more of these cheeses, but I don't know which ones will be exactly like this and which ones will be of a different sort, and I'm afraid you'll be displeased." At which Charlemagne tells him, "Well, cut them in half and look at the insides. The ones that look like this, put them back together using straws to hold them together and send them to me. You keep the other ones." So to recap, Charlemagne had cut off the mold, was going to dispose of it before going back to the white of the cheese, which suggests that the mold itself was not white. But also there was something evidently distinctive about the interior, which they couldn't tell from the outside. The cheese was firm enough to be cut, so it probably wasn't a really small cheese that would have gotten gooey quickly. So it's possible that this cheese was a larger, surface-ripened blue with enough natural cracks or openings in the rind because it either wasn't pressed or not pressed evenly, that sometimes veins of blue found their way into the interior. But apparently not consistently because they weren't being deliberately introduced by piercing. Maybe, no way to know for sure, in the late 800s when this tale was written, the monks who clearly had some familiarity with this certain type of moldy cheese were eating a blue cheese that was much more like the Hallstatt ones made 1,500 years earlier than the ones we most often eat today. Next time we'll head back to Hallstatt and a few other mountain ranges in another Cheeses of the Season episode, where we'll look at the practice of transhumance and what that means for the cheesy girls of summer. So join me again next time as we once again enter the Kurdverse.